So the amplitude, so the amount that it's being displaced from the midline up or down. Well, the midline is going to, in this case, falls on the line x, y is equal to 0. So the amplitude is 1 in both cases. Now the period, which is how long does it take to repeat itself? How long does it take for these two graphs to repeat themselves? So that's what. Okay, to repeat themselves, sine and cosine repeat themselves one rotation of the circle. Okay, and that's what we're doing. We're graphing the x coordinate, the cosine, as we rotate around the circle. So the period of sine and cosine are either 2 pi or 360 degrees, depending upon what language we happen to be speaking. And as you can see by my quick little sketch, there are no vertical asymptotes on those functions. Tangent, a little bit different. The domain is x is all real numbers, except there's vertical asymptotes, certain places. Those vertical asymptotes occur where x is equal to pi over 2. So it would be pi over 2, 3 pi over 2, 5 pi over 2, etc., 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 plus pi n, where n is x cannot equal 2 pi over 2 plus pi n, where n is an integer. So that takes into account pi over 2, negative pi over 2, 3 pi over 2, 5 pi over 2, negative 5 pi over 2, negative 7 pi over 2, etc. Can't list them all. The range. There is no restriction to the range of the tangent function. It goes up forever and goes down forever. Since there is no max and minimum point, there is no amplitude for tangent. And we can't talk about amplitude. We can talk about vertical stretching tangent, but we can't talk about amplitude. The period is pi or 180 degrees. Because when we talk about tangent, tangent is positive, becomes negative, now it starts to become positive again. So it repeats itself in 2 quadrants, where sine and cosine take 4 quadrants to repeat themselves. Basic understanding of our cast rule. And our vertical asymptotes occur where we cannot have it. So the only difference is x is equal to, our equations of our vertical asymptotes are x is equal to pi over 2 plus pi n, where n all integers. So again, you can't have them here because they're vertical asymptotes, so they can't be in the domain, but the equations of them would be. We are going to use these three, or understanding of these 3 graphs, to go through and apply our transformations unit, our second unit to this. We have this, now I've used A and B before, but we often use H and K for C and D, it doesn't matter. Last year in quadratics it was P and Q. The variable that is there doesn't matter. What does it do? So, what does A do to my function where it is? Aurora. Vertical stretch by how much? By A or by 1 over A? By A in the x-axis. Okay, so that's basically, we're going to take our cosine graph and run up and down. So the vertical stretch will affect the range and the amplitude. If I stretch it by a factor of 2, my range now becomes negative 2 to 2. My amplitude is now 2. B. is a horizontal stretch by, is it by B or by the reciprocal of B? By the reciprocal of B. So, of these things here, what is the period, or by changing the B value, which one of them is it going to change? Amplitude, range, domain, or period? I'm stretching it this way. The thing that's going to affect is the period of the function. So changing B affects the period of the function. Because the domain is all real values, it does not affect the domain. C, we have a move right or left. And D, it's a move up or down. Now those ones are a little more interesting because you move something up and down, it affects a whole bunch of things. It affects our range. It affects our x-intercepts. Doesn't affect amplitude nor domain nor period by moving it up and down. Moving left and right really only affects our x-intercepts because our domain will stay the same. It just depends. Our domain is all real numbers. Our period will change, or is only changed by affecting the B. The range is only affected by changing the A and the D value. Okay, so this is kind of what we're talking about here. I've already kind of done it. If I put an A in front of here, the period or the property that will change is the range and the amplitude. Now you'll see me say the amplitude of this function is A because the amplitude was originally 1. So if I stretch it by 2, now the amplitude becomes 2. The range we have to figure out. Here, the only thing that's going to be affected is your period. Well, not the only thing. The other thing that will be affected is your x-intercepts. Because we are taking the graph and either squishing it or making it larger. Oh. Just completing the statement. So if we put the A in front of our functions. Now, if the A is negative, A being less than 0, we have a vertical stretch plus we have a vertical reflection. In the x-axis. Now, because of the properties of sine and cosine, when I have a vertical reflection, I rarely indicate it. If I give you a graph that's being vertically reflected, I'm going to work with moving it left or right instead of vertically reflecting it. And on a diploma exam, I've never seen something that requires you to understand a vertical reflection. It's easier to see moving left or right. Okay, so you make an amplitude change, not for tangent because it doesn't have an amplitude, and we can figure out, as we said yesterday, the amplitude can be found by the difference from the max to the min divided by 2. We have a horizontal stretch by a factor of 1 over b in the y-axis. So if it's close to x, remember that I have horizontally stretched it by a factor of 1/2. So my period is going to be affected by 1/2. 2 pi becomes pi. And again, we don't ever, in sine and cosine, we never really talk about horizontally flipping it because of the symmetrical nature of sine and cosine. They're both symmetrical. How can you tell you horizontally flip it? I take this graph, I flip it over there, it looks like it's the exact same graph. Okay. So by changing the b, we're going to change the period, and because we are doing a stretch by a factor of 1 over b, our original guy for sine and cosine is 2 pi. I'm multiplying it by 1 over b, and we end up with this statement. If I know the b value, I can find the period of the function by just going 2 pi over b. And it's just a simplification of this. Now, we would have the same thing if we were speaking degrees. We don't speak degrees very often, but it is possible. To find the new period would be 360 over b. We are going to horizontally stretch tangent by a factor of 1 over b. The period of tangent was originally pi. Multiply it by the 1 over b, that's our stretch, and we end up with pi over b, or 180 over b, depending upon what we're talking. So, we have a function, y is equal to 4 cos 2x. A is equal to 4, b is equal to 2. Now, this is a nice thing. Amplitude starts with A, so the amplitude is very, very simple to get. We have vertically stretched a graph that had an amplitude of 1 by a factor of 4. It now has an amplitude of 4. The range can be found similarly. We have originally our range is -1 to 1. I'm going to multiply, I'm going to take that bottom guy, I'm going to stretch him down by 4. And I'm going to take this guy, I'm going to stretch him up by 4. So my new range is from -4 to 4. Now by period, we have to do that. Okay, B controls the period, but it is not the period. The period needs to be found by using that concept or equation, whatever. Or taking 2 pi, multiplying it by your stretch. What is our horizontal stretch in this case? 2 or 1/2? 1/2, right? So that's where I get this from. It's either 2 pi over 2, or we can calculate it by 2 pi multiplying by the stretch of 1/2. In both cases, you get a value of pi. Now this is cosine. That is an approximate graph. Now my maximum and my minimum are going to become 4 now instead of 1. So I'm going to start up here. Now, because I'm stretching it, if I just stretched it by a factor of 4, you get a graph that looks like that. So that's just a vertical stretch by a factor of 4. Now I have to horizontally stretch by a factor of 1/2. I'm going to start here and I'm going to go down quicker, up quicker, down quicker, up quicker. My green one is both the stretch and the vertical stretch and the horizontal stretch. So in this case, I'm showing two periods in the same space that I showed one to begin with. Now, most often I'm not going to make you sketch, I am going to make you match maybe. So you have to think, what is the stretch by a half? What is the vertical stretch? Like that. Now, another way of asking these type of questions, we are asking you to write a new function with a given amplitude and period. So we have tangent with a period of 3 pi. For tangent, our equation or our concept is we take the original pi of tangent for our period and multiply it by 1 over b. Well, we know this is 3 pi. Equals to pi over b. Need to solve for b. Get a cross multiplication. Okay. So that's what you're using. That's when you use your equation. When you use your equation. Not necessary to use your equation, no. We have a period of 3 pi. We originally had a period of pi. So I horizontally stretch that by a factor of 3. So my b value must be the reciprocal of what I stretch that by. So you don't need to use that equation if you walk through that concept of stretching. Sine with an amplitude of 4/3 and a period of pi over 2. Well, if I have an amplitude of 4/3, I've stretched it by a factor of 4/3. That's a nice thing. The amplitude gives you the vertical stretch. And that number gives you the amplitude also. We have a period of pi over 2. So, as I said, we can think about what did I do? I went from 2 pi to pi over 2. So I went from 2 things to 1/2 of a thing. What type of horizontal stretch did I apply to that? What number did I have to multiply 2 by to get to 1/2? Yes? Quarter. So I've applied a horizontal stretch by a factor of a quarter. B has to be equal to 4. As my stretch was 1/4, the number that made me stretch it by a quarter is the reciprocal of that. And as I said, you can do this, 2 pi over b is equal to our pi over 2, and solve for b, you're still going to get 4. So our y is equal to 4/3 sine 4x. And I do get into the habit of putting brackets around that, even though it's not required here. When I start adding numbers to it, it makes life a lot easier. So again, we have an amplitude of 0.25. Hey, that's my A value. Nice and easy. This one may be a little bit more difficult to see. I started with a period of 2, we are talking about cosine, period of 2 pi, and I stretched it so I'm now 2 pi over 3. What did I have to stretch that by? might be a little hard to see that that's 1/3. So again, we can set this up. 2 pi over 3 is equal to 2 pi over b. B is equal to 3. So that means I have a horizontal stretch by a factor of 1/3. So in this one it was a little easier because fractions, nice half fractions, it's nicer and easier to see. 2 pi over 3, yeah, we can do it both ways or that other way. Maybe this case would be a little bit easier. So we have y is equal to 0.25 cosine of 3x. Assuming you can read my writing. Okay, so the last type of questions is where I give you a graph and I want you to give me the equation. So we can look at this in a couple different ways. We can either use an equation to find the amplitude, or we can just take a look at the graph. The period, you have to actually look where on the graph and see what it does. The period, or the amplitude, is the distance from the midline. The midline in this case is the x-axis. So the amplitude is 3. The top peak is up 3, bottom trough is down 3. Now you could have also picked this up by going 3 minus -3 over 2. The difference between the maximum and the minimum divided by 2. So we have an A value of 3, whether you do it with an equation or whether you do it with visual inspection. For this one, takes me to there to repeat. Okay. Now it's a little hard to read. On this side, each of these boxes, which may or may not show up on yours, is pi over 2 units. So this is pi over 2, and then this is pi over 2. So it takes me pi units to repeat. Now, I don't know if there's a grid on yours or not. But you can also see, once I erase things, this is pi over 2, so if I double that, I'm going to be at pi. So it takes me pi units to repeat. Going up, going down, going back up. So if I have pi units, I started, well, my original graph was 2 pi for a period. I now have pi units for period, so I did a horizontal stretch by a factor of 1/2. Since I did a horizontal stretch by a factor of 1/2, my b value must equal to 2. Again, we can figure that out by period is equal to 2 pi over b. What does b have to be? Become. So the equation that we have here is y is equal to 3 sine 2x. So what we've done here is what we took yesterday, all right, or what we discovered yesterday by exploring sine, cosine, and tangent. Without any transformations, The amplitude of sine and cosine is 1. The period is 2 pi. The range is -1 to 1. The domain is all real values. Now all I've done here is I've applied my vertical and my horizontal stretches to them. Now tomorrow we'll talk about vertical moves and horizontal moves, which throw a few more wrenches into the works. But, or not tomorrow, Monday, maybe Tuesday, depending on what I see today. Are there any questions before I let you go to the homework? Sean's like 3/4 done homework already. So, whiteboard work, your homework.
the idea here is that some ends can be zero. So there is one zero. They want that's a one that I expect to get people on. and this x is equal to 1 over square root. We have this 2 minus correct. Coming out where I set the triangle of our reference angles, get equal to positive. So we get to here, we're going to go with pi, back up. 2 pi over positive things. Okay. 4. So this one, that's not enough. Get off our step beside. Step to the front. Or rectangle. Insert sign. So you guys can start on it. If you want here, oh, you got 1 over 3. 1 over 3 is just 1 over 4. So now, if you go to the so where cosine kind of on the line, where pi at, I think this is going to look like here. So where is pi at? Because the line is reducing, you're on the right track. I know it's not. These are the ones places where we're going to have undefined values. Cosine gap, so basically, whatever I would expect to look at myself. So that's the end of time of 0. Where is time at 0 on us from our chart? Up here is these two. Fine, remember, we have a unit circle. We're doing circle, square this on the unit circle, click on the back. So this point on the unit circle, cosine is 1, sine is cosine is 0, sine is 1. So our two solutions for this are here at 0. Remember that any point on here is cosine sine. So if it is 45 degrees, square 2 over 2 square 2 over. That's how I remember.